And then the practical realities of the wear and tear of the machines. So that is, through all the sensor data. Move on. So we obviously integrate the pure sciences, physics, chemistry, and in context of pharmaceutical, we have also done molecular level biology principle simulations. But in cement, obviously, it is physics and chemistry predominantly. And then we integrate it with the reinforcement learning deep neural network. We started our journey with reinforcement learning deep neural network, but when we started to get the performance required, we realized that it will not come through the reinforcement learning and all the mathematical equations which exist as part of it, all the different policies as part of the reinforcement learning. So we rewrote the mathematical equation. And through that process over the past 8-9 years, we got to a performance which I'll talk to you about it in a bit. Move on. So these are, the reinforcement learning agents which we build with the mathematical models or the mathematical equations written by BERT Labs. So whether it is, the drive agent or the kill section agent or the crusher agent and the mill agent, and how at a thermodynamic level they talk to each other, and at a software level they talk to each other to create a multi-agent environment as part of our controls. Can we move on? So this is, summing up what I have spoken about in terms of the integration of pure sciences with mathematics and of the CFD simulation in terms of 1D physics, 1D chemistry, some of the tools what we use, and some of the physics and chemistry principles. Move on. Some of the energy and mass balances what we do. Move on. Yeah, move on. Yeah, and then this is bringing together how do we create the operational digital twins. Bhavna, move on. So these are some of the environment models or some of the prediction models which we built. Move on. So this is at an accuracy which is north of 97%. When this presentation was made, at that time the performance was 97%, but it has gone up to 99.99% in terms of the prediction accuracy which is needed in a production environment. Move on. So these are some of the environment models which we build. Cyclone temperature, kills specific power, cyclone. So there are more than one cyclone. Cyclone 5 temperature. Yeah, move on. And then we create the reinforcement learning agent as I shared with you through that framework. Bhavna, move on. So this is where the client stops at in terms of what's the impact. So on the power savings, when this presentation was done, 17.3% is the absolute power savings what we are bringing. Now FL Smith, which is the largest provider to cement company globally, 1864 born, their average commitment, fuel and power is 4%. We, as you can see, for this client, we are already bringing close to 20%. On this, we are showing 17.3%. Our commitment to the client is 20% power savings. And this is, on their existing baseline, and their existing baseline is the DCS baseline or the MES baseline. Move on. And this is a specific power because obviously when there is a variability on production, the power consumption also there is a variability. So we have calculated, the specific power which is 7.8%. Move on. Now this is the fuel savings. Now India is largely thermal. All the variants of coal which is used, and the fuel consumption reduction is to the tune of 18.1%. Now this is revolutionary globally. It's not happening anywhere in the world. I am taking a pause here and stating this. Can you move on? And this is the specific fuel consumption savings with respect to the production. Move on. What the client is interested, whether it's cement companies in India or outside India, is the heat balance and the heat required when it comes to the kiln, because that's the efficiency which we are focused on and the client is focused on. because that is what will bring down the fuel consumption and the power save and the power consumption. So what one of the client, their before bird platform solution, their net specific heat consumption was 720 kilocalorie per kg clinker, which is the intermediate product from limestone to clinker, and then from clinker to cement. We have brought it down by 29 kilocalorie per kg clinker. So now the plant, this particular plant is running at 691 kilocalorie per kg clinker. Move on. This is another client where their before bird platform solution, it was at 711.9 kilocalorie per kg clinker. We have brought it down by 49.5 kilocalorie per kg clinker. So now this is a number globally. You will not find any cement company running at it. All of you can do a research on it, and this will be established. So this is 662.4 kilocalorie per kg clinker. Now the same, in terms of other manufacturing, some of the other manufacturing sectors, which we have built, performing operational digital twins. Bhavna, move on. Performing reinforcement learning agents. Move on. And this is several terabytes of data custodian, which BERT Labs is. Move on. So let's now talk about the impact now on power and fuel. On power, 30% on buildings. Today, as I speak with you, we can commit because of all the development and deployments what we have done across buildings, and buildings will be covered by Bhavna in the afternoon. But on the factory side, manufacturing side, we focus on 20% power savings, and fuel on building will be 20%, and on factories fuel is 10%. That's a commitment which we made. And raw material savings, because the focus is on bringing efficiency on machines, bringing efficiency on the process, the integrated plant. So it has impact on raw material savings, it has impact on overall plant maintenance cost, because you are running the machines at its efficient best all the time. So that has an impact on overall maintenance cost at 25%. Then plant productivity, some of the clients, they want the clinker factor to go up. So that also, has an improvement, by 3%. Then in the next phase of our relationship, because of BERT Nova and the data which it is picking up, the data it is picking up from ERP also. So that is why the focus will be on supply chain efficiency also. Then if you are running, the machines at its efficient best all the time, you are also reducing the capex for your client. So that's what we have experienced, is by 15%. Now one interesting impact which we are bringing for Changi Airport in Singapore. Next time when you go to Singapore and you happen to take your flight from Seapire has close to 130 boarding gates, and if you feel better air quality and thermal comfort over there, it is because of BERT platform solution. So both Amarjeet and Arjun would echo this, that there is predicted mean vote which is defined by ASHRAE, which defines the thermal comfort for and air quality comfort for all of us anywhere in the world. So within this range of -0.5 to +0.5, it defines maximum comfort both on thermal and air quality. Before BERT platform solution at Changi Airport, it was 18% of the times through carrier refrigeration system, BMS system. We have brought it up to 100% of the times. Now again, this is revolutionary. Nowhere in the world, whether it's international airport or hotel or hospital, it has ever happened. And that will be covered very extensively, by Bhavna in the afternoon session. Move on, Bhavna. So these are, when the presentation was made, 134 clients we have collaborated with, and at the POC level, once again, these are the kind of impact which we are bringing, which we are promising to bring. As I shared with you right up front, how we calculate, these numbers. And this is over the next 4 to 5 years what Bert Labs will be doing. So it is, energy cost savings, production cost savings, and the carbon footprint reduction. Because if you reduce power and fuels, you obviously are bringing down, the carbon footprint in the environment. So there's a direct impact. And
in India, for example, for both hotels and quick service restaurants, electricity consumption is anywhere from 10 to 25% of their operational cost. So if you can, and these are the businesses that run in a single digit EBITDA margin. So if you can save a CFO discussion or a CEO discussion, right? So that's where it becomes meaningful. We target typically enterprises. So once you show the proof of concept in 1 store, 5 stores, 10 stores, right? You have hundreds or thousands of stores ready for you to scale up, right? The other is that outside India, then regulations and again truck rolls become very, very difficult. So pretty much any large brand that you may think of is what would be on our platform. That's a sort of a pictorial view of what we would do. So at the lowest layer, you would see the site equipment, which could be various forms of HVAC equipment, refrigeration. So another use case is food wastage, right? So in a lot of quick service restaurants, are you keeping your perishable products at the right temperature, right? By the way, as a side note, because we monitor a lot of quick service restaurants, our team stops going to all of those quick service restaurants, right? So you know what's happening in the back office and you don't want to eat there. So all these typically, the problem that has been stated over the last day and today also is that many of these equipments may not talk. Sometimes these equipments would have standard communication ports like Modbus or BACnet. Wherever that exists, we would pull data from there. Wherever it doesn't exist, typically what we would do is put in a sensor at either input or output or both, right? So let's say it's an air conditioning. What do you want to monitor? You want to monitor the input, which is the electrical consumption. So you can put in a energy meter at the circuit of the air conditioner, and what's the output, which is the cooling, right? So you put in a temperature sensor in the ambient, right? Then in between, whether the air conditioning is a Daikin or a Voltas or Blue Star, doesn't matter, right? Of course,
that's very, very interesting presentations. So as I think about clearly these presentations demonstrate the potential of energy efficiency. So let's say my 4 questions. The first question is, from your point of view, in your various sectors, you're talking about small and mid-sized buildings, you're talking about industry. Clearly in your case, the adoption of your solutions has been driven by corporate reasons, right? You said, 1 to 2% savings in your EBITDA becomes a boardroom conversation. In your case, you give the example of 8 to 18% or 20% improvement. So clearly, any company will think about that. But I'm just wondering about, one, what might be the role of public policy in accelerating the diffusion, rather than companies actually saying this is beneficial for us, but how do they know, how do they actually trust the data and all of that? So one is a public policy question from that perspective.
If not companies that started the lab, the companies that have grown up in the community, all in this clean energy space. So again, and that's sort of a virtuous cycle. So how do you scale that? I don't, there's an existence proof that